Okay. So yeah, I guess I'm going to take the meeting minutes and manage the queue. Brian, you are going to share, as you guys are all aware of. This is just a continuation of our conference call series because of the cancelled March IETF meeting. And based on request, we are going to talk about Depop again. And you may have also seen the announcement about the upcoming IETF meeting, which will also be online. So we'll have to run another doodle ball to figure out what suitable conference call meeting slots are. And yeah, do that for the next few months as well. Tony, since you joined, I don't know if you have a chance to also help me with the meeting minutes. Or anyone, actually. I've posted the link into the chat window. Okay, perfect. And I will hand over to you, Brian.
Okay. I assume, I don't know, you don't need to do a note well or anything.
Yeah.
Just assume we're all noted well.
Yeah, the rules are the same for the other conference calls we had. So the IETF note well applies. I'm not going to share any working group slides because there is only one topic today, as everyone knows, posted it to the list. So I guess you're not by accident in this conference call.
No, I just I didn't know if we needed to do anything formal to make sure. I don't know. Silly of me to think.
As formal as it can get here now.
Fair enough. Fair enough. It's always a little uncertain on this side of things. Are slides showing up for folks?
Yep, works.
Okay. Yeah, so back at it with Depop. We're gonna try this again because we ran a little short on time last time we went through it. I'm gonna give a bit of an overview again, try to level set where things are in terms of the document and how the interaction and protocol works right now, and then discuss a quick status update of kind of how we got to where we are with the document, and then roll through some open issues of sorts or open questions and see if we can get some input, feedback, and maybe even get to some consensus on where to take those things to the next revision of the document. So with that in mind, here we go. So what is Depop? Basically, we're talking about an application level proof of possession for access and refresh tokens in OAuth. And the little diagram at the bottom here shows a normal OAuth flow where you have your token request and you get your access token and you use your access token to access a protected resource. The key change here is that this thing called a Depop proof flows both on the access token request as well as the protected resource request, and in turn the proof itself is JWT that's sent as an HTTP header, and this demonstrates a reasonable level of proof of possession in the context of the particular HTTP request. It's sent the same way and with the same syntax and semantics for both the token request to the authorization server as well as for the protected resource requests. It's a job, look at the details in the next slide, but basically the AS can use that proof to bind tokens to the public key included in the Depop proof, and in turn the RS can use the proof to verify the binding and bound tokens that it receives on protected resource requests. That Depop proof is, again, it's sent as an HTTP header, but it itself is a JWT, and here's a look at sort of the exploded semantics of it. It's explicitly typed because that's what we're doing these days. We're supporting asymmetric algorithms only for signature algorithms. And then in the header is the public key as a JVK member the public key for which proof of possession is more or less being demonstrated. So the key is included in line in the header, basically saying this is the key that was used to sign this token. And then in the body, there's JTI, a unique identifier that right now is being used for replay checking. And then there's a minimal amount of information about the HTTP request, basically the method and the URL or URI of the request, omitting any query or fragment portions. And then there's a timestamp that is there of the issuance of the proof, and the server side, either authorization server or resource server, is free to accept proofs for some minimal limited time window relative to the creation time. So there's not an explicit expiry, but an expectation and requirement that the issuance time be used and only accept these as valid for some minimal period of time around the issuance time. And it is potentially extensible, but this is what is specified in the main content of the proof itself. So then that proof is sent as an HTTP header in with the name Depop, and in an access token request, there's an example there of, you see the proof JWT in the header, and then the normal stuff you'd normally expect in an access token request. This is an authorization code request. And that allows the authorization server to verify that this client holds possession of the private key corresponding to the public key that's in this Depop proof, and can in turn bind the access token that it issues to that public key. And the access token here is an encoded JOT, and you see the token type here is Depop, used to differentiate that this access token type itself, or this access token itself, is bound to the Depop public key. This could be the same thing with reference style access token. This is the exact same response, just with a shorter access token here to demonstrate that it's not specifically required to be a JOT. It could be either a reference style or opaque, and ultimately to the client it's opaque. But here we can deal with any kind of token, but the token type still indicates Depop to indicate to the client that this is in fact a Depop bound access token. For JWT and introspected access tokens, we do, in the sake of sort of interoperability and commonality, we define the confirmation method that carries this confirmation method claim that carries the SHA-256 JWK thumbprint hash of the Depop public key to which the access token is bound. So when using JOTs as access tokens, the confirmation claim indicates the binding to the public key through a hash of the JWK thumbprint, and then the same information is conveyed in the form of an introspection response to indicate the binding. Of course, if the AS and RS are conveying information about the content of the token in some other format, database lookup, whatever, certainly they're not required to use this format, but this is provided for the sake of interoperability around JOT style access tokens and access tokens which are introspected. A protected resource request, once the client has obtained a Depop bound access token, it sends it in the authorization header with a Depop scheme. This is the JOT from the previous example a few slides ago, and also sends in turn a Depop proof, and doing the same syntax, semantics, and header name as it normally would to send that proof in the header. And this, then you have the access token, which is bound to the public key, and proof that possession of the corresponding private key is provided in the Depop header here. This is just showing that this could, of course, be a protected resource request with a smaller reference style access token. It doesn't have to be a JOT. Presumably, then this would be introspected to figure out the details and the binding, but the proof is sent the same way. And the proof, again, provides proof of possession of the public key, or the private key corresponding to the public key to which that access token has been bound. So that's a quick overview of how that thing works, some current recent status and updates and so forth. So beginning of April, we moved this draft to a working group draft. Leading up to the last interim about the document, tried to push out a one revision, a lot of editorial updates, some key things that were done. We more formally defined the Depop authorization header scheme, so it's in line with the expectations for what actually is needed to be done to define an authorization request or authorization header. And that included also defining the www authenticate challenge for that same scheme. And worth noting here is that challenge can include an OAUTH parameter, which is a way for the resource server to indicate the supported signing algorithms that it supports for the JWT, or sorry, for the Depop proof JWTs. There's not a similar challenge response mechanism necessarily enabled for the authorization server, because things are happening in a little bit different layer. So we added a Depop signing out value supported authorization server metadata value. So this gives the same information, but for the authorization server and in the authorization server metadata lookup to understand what signing algorithms are supported there. A few little minor things, added a error code for token or errors from the authorization server in the token request. Did some stuff to IANA and moved a few things around. During this time period too, there was a IIW session that unfortunately I wasn't at, but got some feedback secondhand, much of which was posted to the list. Thanks, Mike, for doing this. And we'll be trying to touch on some of the things that I understand came up during that session. So it sounds like it was useful. This was discussed, as many of you know, during interim session on May 5th, but didn't get through a lot of the content just due to time constraints. And some feedback on this was received around the same time. So kind of a combination of those three different items in the last. There's been some feedback, questions, and so forth that I'll try to at least get to or summarize the various open questions and see if we can I don't know, try to push forward and get to a little bit more consensus about where we want to handle some of these things. So one of the early issues and questions we've had early on is what about the threat model and overall objectives of this document? Obviously, there is a lot of room for improvement and clarification in the document itself. And honestly, I'm hoping Dr. Fett here can help with writing and rewriting these parts of the document, because he's much more versed in that kind of work than I am. But just for the sake of this particular presentation, I borrowed some of this content from this publication that he shared with the list a couple of weeks ago that describes mostly the attacker model. Daniel, feel free to jump in if I misrepresent anything here or you want to add to it. But basically, there's a couple of key attacks that or models of the attacker that this would outright mitigate. And one would be a misconfigured resource endpoint, either through social engineering or other kinds of mistakes. If an access token is sent to a resource server controlled endpoint, that endpoint could not in turn turn around and play it to the original the legitimate resource server for that, because it couldn't reproduce the proof with the appropriate content. Similar in nature, but maybe coming about through different reasons. If a resource server was intentionally malicious or possibly just compromised partially, by some internal actor or something, this Depop would prevent the replay of legitimate access token across from that compromised resource server to a legitimate resource server. Potential other things were like if a TLS termination is done within the same sort of trust boundaries as the resource server, but at different components, which is a fairly common deployment. If that particular component were somehow compromised, it says here, for example, maybe by a buffer overflow or something in the reverse proxy itself that's doing TLS termination, that again could be prevented by preventing that particular place from replaying the token from there to endpoint, resource server endpoint, at which it was not intended to be used by the client itself. We have the sort of stolen token model. So obviously a bound token cannot be used by an attacker who just gets the token itself without also showing possession of the private key. So a browser-based client with a JavaScript client, if tokens are exfiltrated themselves, they cannot be used by the attacker without corresponding access to the private key. So if tokens alone are exfiltrated, it prevents the attack of them being reused. One area that it doesn't prevent, and I guess the question here really, and I'm not sure there is much of a question other than to say this particular type of attack is out of scope, where it's an online cross-site scripting attack, where rather than exfiltrating the tokens themselves, the attacker simply drives, I say simply, it's not simple, but it's certainly possible, drives the entire attack through the browser and JavaScript client. So the tokens aren't stolen and reused outside of the context of the browser, but are used directly within the context of the browser, and in turn that provides access, presumably, to the corresponding signing key for the Depop proof. This is sort of a reductio ad absurdum kind of thing, because pretty much any type of security mitigation that has that's susceptible to an online XSS style attack is itself there's not much that can be done to prevent this other than preventing the original vector itself of the cross-site scripting attack. I guess it's sort of a middle ground of those two would be trying to understand whether or not we need to prevent the idea of pre-computed proofs. So consider the same kind of attack with cross-site scripting, or perhaps maliciously loaded JavaScript that could exfiltrate tokens and also exfiltrate pre-calculated proofs to be used later from a third party. And this is possible now, conceptually anyway, because the proof itself doesn't contain any particular server-side generated or server-side provided proof of, not proof, but nods or other entropies. So it's possible that if you had access to the use of the private key without being able to actually steal the private key, but you could pre-compute Depop proofs that would be valid at particular resources and at a particular time later on in the future, and then exfiltrate that in conjunction with the bound token and use those independently later on. Although it's sort of, this is possible. Given if the vector is possible, then the nature of the proof would allow this to happen, because there's not a server-side generated component into the proof. Catch up around. There's also the possibility that exfiltration happens somewhere else outside, otherwise from the secure channel. One example here would be like the breach attack against HTTP compression. If a token is just stolen through sort of this or other types of means, while not correspondingly getting access to use or steal the keys incorporated in it, obviously we can prevent reuse of that token by itself because of the binding to the proof that wouldn't be able to be provided by the attacker in that case. So that's my attempt at wading through Daniel's attacker models. Moving on to an issue that I sort of want to put out here because it's there, but maybe put it behind us for the time being. and that is that symmetric cryptography is significantly orders of magnitude more efficient than asymmetric cryptography. And this has been raised as a potential problem for deployments with DPoP because we are using exclusively asymmetric cryptography, public-private keys, and need to use them on every request. And this is true, but there are other costs and complexities involved in getting to symmetric keys. So, there's trade-offs involved. Right now, we've sort of settled in on the asymmetric model. And while it's true that it's significantly slower, less efficient, there's no argument around that. The actual real-world implications of how it could be deployed and used haven't actually been quantified. So maybe it's a little bit of a kick the can down the road, but it's still usable and deployable. We don't know how difficult or at what point it becomes problematic. And so it's sort of a theoretical objection at this point. There are a couple different potential approaches that we could take. I list two of them here. There's probably many more, but if we were to look at trying to get to a symmetric type approach, and one would be the key distribution type model that we've discussed for a long time, but has some drawbacks, in particular that it is difficult to get the key distributed to the right parties without in turn undermining the value of preventing the RS to RS type replay situations. And then there's a key agreement model that Neil suggested looking at a while back that in some ways is more complicated because it requires a few steps to get to an agreement, but to agree on a key, but it allows for that key agreement to occur between the two parties involved and provides many of the same types of benefits as the asymmetric model that we're using now. So I guess I would say if we do circle back and try to do something here, the key agreement model in my mind is a lot more appealing because it provides more value. But that's me, and it's sort of moot at this point because I'm considering this whole issue sort of closed, at least for now anyway, coming out of the meeting we had before the what was to be one of IETF 107 in Vancouver that didn't happen. We had a week or two before that. And basically, the consensus through that meeting and the subsequent call for adoption was to move forward with the DPoP document, more or less, obviously, as it's currently defined. So we're going to sort of forge forward with the asymmetric functionality for now, and sort of put this question behind us at least for the meantime until we can get some real implementation and deployment feedback and see if it is in fact really problematic or not, at least for most deployments. Somewhat related, but also its own issue, is that there's been questions and issues raised with the difficulty of the current, or at least perceived current, nature of the JTI, the JWT identifier claim. And it's used now to allow a server to detect replay. So the idea is that the server would track JTI values and reject requests when it sees a duplicate JTI. This can be very problematic, particularly for large-scale deployments, because it requires state management across distributed nodes. And this in turn can also exacerbate inefficiencies around the asymmetric crypto problem. If the signing can be inefficient, but the ability to just scale out nodes is certainly a possibility to just throw more compute power at it to deal with the cost of the asymmetric crypto. But if you're being required to synchronize state to track the JTI values across all those nodes, you sort of undermine some of the improvements you get from that scaling out operation. So the current situation we have this right now is we also have the issue.time, which also allows for limits the replay window, not specifically the replay of any particular proof, but it certainly ratchets down the window and the possibility of any replay happening. We are not trying to replace TLS at all. The proof flows from the client to the server. And so the need in that context is a little bit unclear if there's really a true need to do sort of the one-time use prevention on any one particular proof. And the current text in the document does say that the replay check and prevention on JTI, it's not a must, it's a should, and in places it's qualified with text like, do this within a reasonable consideration of accuracy and resource utilization, that if you see the same JTI value, that reject it. The idea being there that it leaves implementations with some wiggle room to do this checking to the extent that they feel is reasonable with respect to the rest of their architecture. So if you had large scale horizontally distributed nodes, perhaps you would only check and retain, JTI prevention cache locally on each node. So it provides some level of protection, but not with the overhead costs of trying to synchronize state across those. That was certainly the idea in writing that with the should, and the qualifications was to allow for those kinds of decisions to be made without violating normative requirements of the protocol itself. So I'm a little unsure where to go with this going forward. We could do some things like explicitly mention that the space that you need to check for is qualified by the URI and method, which also reduces the scope of the data replication needed. Like if you don't need to check JTI value for different hosts or even different paths. So you don't necessarily have to replicate or manage it as wide as the current document might suggest. We could further loosen or qualify the requirements I talked about before, like maybe moving it to a may, or even sort of non-normative text, just indicating that it's an option, but not requiring that the prevention be done. We could potentially drop the tracking requirement altogether, and I think we would still keep JTI just to provide some. Neil pointed out some nice improvements from just having additional interest P in the proof itself. That it's still probably good to have it in there, but we could just be silent on it and not say anything about suggesting, requiring, or otherwise having to sort of track those for replay prevention. And of course, there's always the possibility we could do something else that I'm not even thinking of here. Another issue that's come up through some of this is that there's maybe a desire or concern that there's no signal that the refresh token is bound. This came up, I guess, in the IIW discussion, but I've heard it a few other places, that it'd be useful to have DPOP-bound refresh tokens and bare access tokens, sort of as a transitional step. But it seems like the spec requires the same token type for both access tokens and refresh tokens. Just wanted to note that the token type itself applies only to the access tokens. So from the original core spec, we are indicating with DPOP that the access token itself is DPOP bound. The refresh token, there's no, it can be bound or not bound, but there's no explicit signal, and it's not in turn related to the token type itself. So that leads us to a situation where we have a document that prescribes binding refresh tokens, but only for public clients. I think this is an area that needs to be clarified a little bit because some questions have come up, but the idea is that refresh tokens themselves are bound to the client per the base specification of OAUTH. And so in turn, if the client is a confidential client with its own credentials, the refresh token is basically already sender constrained and bound to that client and its associated credentials. But to add a little bit of improved security for public clients, using DPOP, we can bind the refresh token to that client's public DPOP key. So I just want to, I will clarify and break that out a little bit better, but pointing out that this whole idea of binding or not binding refresh tokens is constrained to only public clients. What was I trying to say here? It is certainly, I think, reasonable to expect that DPOP access tokens themselves could most likely be usable as bearer access tokens for resource servers that only support bearer access tokens. So I guess the scope of need, the potential need for unbound refresh or unbound access tokens with bound refresh tokens is even maybe further limited here. But having said all that, there are still cases where it's possible that a public client would be requesting access tokens, wanting to get bearer access tokens, but still potentially benefit from the value of having its refresh token bound. And really the question then is, does the client need some kind of explicit signal to say that, hey, this refresh token has in fact been bound to the Depop key that you provided? And certainly one option here is token endpoint response parameters are extensible. It's an open-ended thing, so we could add a new parameter as a signal to the client that gives the client an indication that the refresh token that's been sent has been bound. Hopefully, I know I'm bad at naming, but hopefully the name here is understood to be a joke, but it could be something like this, just a Boolean value indicating it's a bound refresh token, or maybe even a more explicit signal like, sending back a hash of the key. So it would be like the Depop, more or less the same value that you see in a confirmation, just indicating that, hey, this is the key to which confirming that I did bind this refresh token. So that it's sort of, I guess it's we could either add something there or leave it as is, and it's sort of an implicit signal versus a more explicit one. I'm not sure what is necessarily better. Another area of discussion that's come up is a desire for client metadata. I mentioned earlier there's a number of authorization server metadata fields indicating both the actually I think it's just the supported algorithms, but people in general have said they're supportive of defining client registration metadata that might somehow declare support for Depop in the client. I'm really struggling to understand how this would be used in practice. The client sort of can signal its ability to support Depop through the presentation of the Depop header when interacting with the authorization server. So I don't know what a client metadata value would be used for independent of that. I felt like I needed to sort of give the issue its due here, but short of someone being able to articulate a legitimate need or use, how it would be used, I'd like to sort of put this one behind us.
Brian, there's a question from George.
George, by all means, I assume it's about this 24 here.
This one and a little bit the one before. But basically, I think somewhere in here, the other complication we have is OpenID Connect with dynamic client registration, right? Using asymmetric keys creates this interesting dilemma because you can use private secret JWT for your client authentication method, which is sort of like Depop. So specifically to that client metadata perspective, the way that a DCR client may interact with the token endpoint as it relates to proving client authentication may be a private secret JWT, but are we saying that in addition, if they want Depop, they have to send a Depop? And if it is Depop, do they use the same, the same key pair set, or is it a different key pair set? So, in a single page app, right, well, even in a single page app, you potentially could attempt to do dynamic client registration. The ITP putting some issues on local storage, right, might make that not really viable. But other browsers, as it stands today, there isn't anything to say you couldn't use local storage in IndexedDB as effectively your storage of the keys as they relate to doing an actual dynamic client registration in that browser, right? And so I think we have some interesting overlaps there that are a little bit unclear how we sort them out. So I think that it does add some complexity, and in that particular scenario, right, having the client be able to say, you know, I want to do Depop, I want a Depop bound token because I'm going to use Depop for my access token validate, you know, for my access tokens to the resource servers, but I'm going to do client authentication because it's a confidential client with my DCR keys, right? And I want to use those same keys for, you know, Depop, or maybe we shouldn't allow them to use the same keys. But I do think there's some complexity here.
Okay, so I mean, one thing as currently written and also by design is that the client authentication is completely independent of the Depop binding mechanism. So in a case where you had a client, however it was registered, but a client that was using JOT private key authentication, that it remains unchanged. It would be the same regardless. And if it wanted to bind tokens, it would send in conjunction with that and independent of that, the Depop proof header for binding the access tokens. We are currently silent on whether you could, should, or should not use the same key for that. But it would be, it's sort of up at the client's discretion at this point. So
And that's fine. It's an awful lot of weight, right? Because the Depop header and the, you know, private secret JWT are going to be similar, though not the same, if the keys are being reused.
Yeah, yes, that's true. They are similar, although they are not the same. One is basically trying to show you authenticate by the use of an asymmetric signature back to a key that was somehow previously registered. So you're saying, hey, hey, I have this key, and you know that it's a key that you should have for me, so that's my authentication. Where the Depop header itself is basically just a self-contained unit saying, hey, I have this key. Oh, and by the way, here is this key, and please do what you will to bind tokens to it. So I agree that in the case of that particular authentication type being used with Depop, it's a little, I don't know, it's a little verbose. There's a little bit of redundancy there, but I personally, prefer the commonality and not trying to special case or build something else that would allow for a special case around that particular way of doing things, and rather just keep it consistent.
Sure, that's fine. And I think the other one that we may want to we can defer to later really gets into the sort of like, rollout strategies, right? And should we really be telling resource servers to take a Depop bound token and just treat it like a bearer one or whatever? So I'm happy to defer that to some other period of time, but that is another.
That is actually, I think, either the next or some discussion of that's coming. So in this very slide deck, so I think it's an important point I would like to discuss.
Cool, thanks.
So we were, in fact, here it is. A lot of words here up at the top. I don't know why I did that, but just trying to get a bigger picture understanding of what downgrades and supporting of sort of transitional rollouts or even long-term mixed token type deployments, where you might have resources that require Depop bound access tokens and other resources that are just going to be bearer tokens forever, being served off of the same authorization server. We want to be in a place where we allow for that to happen and also allow for transitional rollouts, so it's not like a big bang on or off, because that sort of thing rarely actually works, but allowing for it to roll out over time or even indefinitely support a mixed mode is, I think, really important. The main issue here is that there's basically not much in the document discussing this at all right now, and that lets people make their own assumptions about how it should or shouldn't work that oftentimes don't match other people's assumptions. So what I'm looking at, suggesting, I guess, doing here is make it clear that an RS, which is Depop enabled, so a DPOP enabled RS that wants to also support the bearer access token scheme at the same time, so simultaneously supporting both, does need to update its bearer token evaluation functionality and do so in a way that it will reject bearer tokens that are DPOP bound. So if it'll look at the token and find a confirmation scheme. If it's bearer and it finds the DPOP confirmation scheme, it needs to reject that. But that would be, unique to changing functionality of the bearer token access for those servers that are also supporting DPOP resource servers. A DPOP, an RS that's only supporting DPOP is only gonna accept a DPOP token. So I think things are okay there as expected, maybe a little bit more wording around that. But then an RS that's only accepting bearer tokens will most likely accept a DPOP bound access token as a bearer token. This may not always be the case, but in general, JOT indicates that you should ignore claims which are unrecognized. The bearer token scheme itself is silent about any sort of binding, and introspection isn't say much one way or the other, but certainly talks about and makes allowances for additional information being present in the introspection response, which more or less just means that there could be other claims in the token, and here they are. So it's not a guarantee, but I expect and would expect that the vast majority of bearer token only accepting resource services would in turn accept a bound access token as a bearer token. And while this seems a little scary and maybe counterintuitive at first, I think it's actually a major plus, because this helps support sort of mixed transitional type deployments. So a client could, without having to request more granular tokens based on specific knowledge of the resources, it can still continue to get sort of the token scoped the same way that it normally would, just DPOP bound, and use those as appropriate at the particular resources. And so it could get a bound access token and use it just as a regular bearer token on resource servers for which that's all they accept anyway. And as I fall over my words trying to explain this, I realize it's going to be hard to sort of write in a meaningful quality way in the document, but I think this is where we want to go to explicitly talk about how these kinds of things can be supported. And that really just boils down to mentioning this fact about bearer. And sorry, go ahead.
I hate to interrupt you, but we have a number of people in the queue.
Very well. I manage the queue, my friend.
Philip?
Philip Skokan, Zero here. I agree with your assessment that most resource servers will likely accept the DPOP-bound AT as a bearer, but this highly depends on the client implementation and whether it actually uses the token type that it received as the authorization header scheme, or it just uses bearer as a fixed value. If it actually uses the token type as an input to its authorization scheme, then this will most likely break.
Yeah, yes, although I expect it would break, it would fail sort of closed. So if the client is operating strictly off the token type, it would send to a resource server this as a DPOP style.
The request would fail because it's a DPOP style authorization. There's no DPOP header.
Exactly, and the resource server in turn would challenge with a 401 and bearer authorization scheme request.
I absolutely agree. So from the perspective that there is going to be an unauthorized access, we're absolutely okay. It's just, it's not a seamless transition for those types of clients if they receive token type DPOP. But at the same time, if they do, they need to be sending the header. Yeah.
Yes, I think yes. I think I agree with you. I'm seamless. If I said seamless, that was probably too far. It more seamless with respect to the resource server, I guess, being able to handle it. And the client will, yeah. I mean, the client's going to need to have some smarts or change its behavior some to make any of this work. So it seems, I guess I feel like it's okay, but if the, are you,
the client needs to know that this authorization server doesn't support, that this API doesn't support Depop, and it's still going to use the Depop access token or the Depop bound AT, but it needs to use the bearer scheme.
yes.
And this sort of transitions into the need for client metadata or some sort of signaling where if I know I'm going to be using this access token and a resource server that doesn't support Depop, I either need to know and use the bearer scheme, or I want to tell the authorization server not to bind the access token. And if I'm a public client, maybe I just want to bind the refresh token. So yeah, they're not sure how to.
Okay, so yes.
Well, while you think, maybe do you want to hear the George and Justin? They are also seems to be commenting on the same issue.
I don't want to stall the discussion, so I'll make my mind and speak up on the list with the well-formed idea.
You can say it here as well, but I think there are a few others who have some thoughts to share on this as well. George, do you want to add to that point?
Sure. I guess I worry a little bit about the client trying to know which resource server it should do what. I mean, I'd be more tempted to make the resource, I mean, yeah, the client know, whether it should switch the authorization type from bearer to Depop as it's going to different things. I mean, the sort of hope of OAuth was that the client is rather, dumb, and this is starting to add a significant amount of smarts into the client as it relates to delivering things. Is there a reason we couldn't just make the resource server accept both Depop and bearer as inbound authorization types? And then, and you do that before you start your rollout. And then even if it doesn't actually support Depop, it'll just take that token and validate it. And then if it gets support for actually processing Depop headers or however it's going to manage that, right, then it could add it in and add your other rule, right, that basically says if I'm supporting both, then, I do the right thing with them. But I just worry about making the client have to do this switch.
I'm not sure. I don't know exactly.
That's okay.
I mean, if it's a resource server, sorry. Go ahead. I'll concede. I was just going to say, if it's a resource server that you have no control over, right, and you're trying to roll this out, that's a different scenario than the case of resource servers that you control. So, we might need to consider both use cases from a recommendation perspective, and I'll pass the ball to Justin.
That's fair.
Okay, so yeah, bunch of stuff, but also want to be aware that we have never let Brian finish a presentation. So how many more slides did you have?
Not that many, so we might still make it.
Okay, so bunch of little bits to comment on, and I'm happy to bring this to the list as well. So first off, about this downgrade thing, it's my stance that the client should never do a downgrade of the Depop token, and that it would be up to the resource server to decide that it doesn't want to check the Depop proof for whatever reason, or it can't, and it's fine with that, because that's not a decision that the client should really get to make. And it puts the client in a really awkward position of being way too smart about security than all of OAuth ever expects the client to be. And that's not a place we want to put the client or client developers. A quick callback to the JTI issue a few slides ago. I think that the recommendation as currently written in 01 is good, and that most of the concerns can be security recommendations about properly bounding the time window for that. Because honestly, I think that the fears of, oh, I have to remember every number for all time forever are it's absurd fear mongering, and we need to move past that. We can have good recommendations for reasonable people to build things, because that's what people are going to do. Could you go back a slide or two, please? There's one other small bit. Oh yeah, the client metadata and all the signaling stuff. I definitely agree that we're in a weird corner with both the client saying that it can do Depop and the tying things to the refresh token or not. A lot of this comes down to just limitations in OAuth's data model. Brian, as I know that you've said, we didn't really have a client data model until we had to invent one for dynamic registration. So we're kind of stuck with that as the place to hang things. And we don't have a good token response model that's separate from the single access token. So I don't have a good answer for either of these, but I do think that we need answers for both of these. And unfortunately, I don't think that there's a clean way to do either of these problems, the bound refresh tokens or the client signaling its capabilities and intent. I will say, as coming back around to the first point again, a client that only knows how to deal with bearer tokens will never get a Depop token in the first place. So that's not a use case we have to solve for. And so going back around, it's more, what does the authorization server need to expect and enforce? So that's my stack of huge comments.
Thank you. I'm trying to internalize some of those, I think, or at least went through my head, but I think I follow most of it. Okay, yeah. Sorry for the fire hose. I will try to engage on these points on the list and with the draft as it moves. Because I think a lot of these are going in the right direction. I'm really, really scared about the downgrade attack, though. Counting on a client to do the smart thing in terms of security is guaranteed disaster. So my thought there is counting on the client to do the right thing in terms of getting shit to work, interoperability, and counting on the resource server to do the right thing for its supported security model. So yeah, it is a little bit different. So that's why I was saying that the client that gets a Depop token should always, always, always send it as a Depop token. Should never send it as a bearer token without the proof. And it's up to the RS to decide how much it cares. But an RS is going to need to be able to look at the authorization Depop type field, and it can decide to ignore the Depop header if it wants to. Heck, we've got RSs that ignore signature validation and issuers on JOT access tokens today because they want to. So the RS should make that call. The client should not. The client should always send a Depop token as a Depop token. The part of the thinking here, though, is trying to keep things working for RSs in a world where the RS is completely ignorant of the existence of Depop tokens. Some will be updated, some will be, you know, could do what you suggest, but others will not. And wanting those to continue working in a world where the authorization server and some clients are moving to be able to use Depop all or some of the time, but a resource server that's not being updated could still continue to work. That I think is the more pressing goal versus updating resource servers to do Depop, but ignore the depopping.
I think there's too much black magic and danger that lies down that road. I get what you want to do, and I think if resource server is going to accept a new type of token, it needs to know about that, at least know where to look for that type of token.
Yes, absolutely.
Right, and if it can look for the token in that field and it's fine with doing just that, you know, it looks for the string Depop instead of the string bearer, and everything else is fine, then that is a minimal code update, but still an important update, because then you've at least identified that, hey, here's an RS that is doing, that needs to set new tokens. I agree that George's point about RSs that you don't have control over is an interesting one, though.
Yeah. Need to think about and discuss this some more, because I think I disagree, but we're running low on time here, so this will be an ongoing discussion. How are we doing on the queue?
Yeah, now the queue is empty, but the time is also over.
I got like a minute. Shoot, actually, that's a big one. Okay, we're done.
I took some notes. I will send them to the list, and I've been trying, unfortunately, unsuccessfully, to upload the presentation. I will try it again, and we'll send a mail around once this is done, so we can look at the rest of your slides, Brian.
Okay, looks like there's.
In any case.
Yeah, there's just a couple more.
Okay, some more pictures. In any case, I would like to thank you for the participation and then for the discussion. And we are going to send around the doodle poll to figure out what other suitable conference call dates could be and when to start them. And obviously picking with the overall IETF strategy on doing those, given that there are other groups will have to also schedule meetings, so we may have some conflicts here. Anyway, thank you all, and talk to you soon.
Thanks, Thomas. Thanks, everyone.